I'd love to maybe start with what that is. I mean, who's the sort of like data and data engineering and machine learning infrastructure team at Netflix? How many people? How is that organized?
Yeah, sure. So when you think about, say, machine learning and Netflix, like the first thing that jumps out is our recommendation system, and Netflix has invested pretty heavily in that area over the years. But then, given that Netflix is a big organization with a global footprint, you can imagine that now we are using machine learning in various different parts of our business as well, right? Like that's like one of the biggest subscription service. We have to like address fraud, and that's where we use machine learning models. How can we sort of like be more effective in customer service? Those are also some areas where we rely on some machine learning model to sort of like better assist our customer service agents, as well as analyzing how our content is performing, or like how do we sort of like cache content on our content distribution network. So right now, if you look at, say, machine learning at Netflix, even though recommendation systems still sort of like the bread and butter of our investments, there's still sort of like this strongly growing area of data science usage, which can be characterized as more or less as like business data science. And my team, the machine learning infrastructure team, is essentially tasked with building infrastructure for that particular use case. Now, in terms of the folks who work in machine learning in this area, predominantly these are people who have sort of like advanced degrees in machine learning, masters, PhDs in various quantitative disciplines, and their chosen vocation is machine learning and not necessarily software engineering. So how can we sort of like make them more productive as they sort of like go around getting their work done on a day-to-day basis? So that's inherently the charter that my team has.
Cool. Actually, as a technical thing, could you come a little closer to the mic
Sure.
to increase the volume? Thank you so much. Very, very good. So, how big is that team, that machine learning infrastructure team?
So my current team has 6 engineers right now.
Okay. Very good.
So we are a fairly small team, but then most teams at Netflix are IT.
Okay. Very, very good. And so we're going to talk about Metaflow specifically, but maybe before that, could you, to the extent you can talk about it, could you give us a sort of a broad overview of the data stack, including the machine learning part, but not just that, like including analytics? What are some of the tools that I use, some of the open source projects that I used across Netflix?
Mm-hmm. Yeah, sure. So when it comes to, say, the stack that's available to our data scientists, like first and foremost, it starts off with our data platform, and Netflix has built a very comprehensive data stack. We are an AWS shop, so we use S3 as sort of like the storage layer for our data warehouse, and we use Spark, Presto, Snowflake as our query engines. And we have invested pretty heavily in data discovery and data cataloging. MetaCat is a Netflix project that's involved in data cataloging. So all of the data that's stored sort of like gets enumerated over there. Then when it comes to query engines, as I mentioned, Spark, Presto, Snowflake, those are sort of like some of the query engines that people prefer using. In terms of compute, our container orchestration platform is called Titus, which is yet another open source project. So it runs Docker containers. So our internal users, they'll essentially launch either their batch workloads or their services on top of Titus. And then when it comes to, say, workflow orchestration, as with any big company, we have a bunch of different workflow schedulers that are used internally for most of our ETL workloads. We have a workflow scheduler called Meson, which is sort of like
What? Sorry.
Meson, which is a
Meson.
homegrown scheduler that's being used to drive all of our ETL as well as machine learning pipelines. And yeah, so that's sort of like the basic stack that we have. We are also very heavily invested in the notebooks ecosystem. So we have a number of Jupyter contributors working at Netflix, as well as we have yet another open source project called Polynode, which focuses on Scala first notebook experience. predominantly geared towards machine learning researchers as well.
Mm-hmm. Great. Thank you for that. So let's talk about Metaflow, which is one of an open source project you've been looking after with the team. And interestingly, which I think some overlap with the Kedro discussion we just had, although that was sort of the randomness of the scheduling. So maybe start with what is a fundamental need, leading to the product, and then we'll go into what it actually does.
Sure. Yeah. Like even before my team existed, Netflix had the data stack, compute stack, workflow orchestration stack, which was widely available to our internal data scientists. So if, say, you were a data scientist at Netflix, then you could, in theory, use a Jupyter notebook, get access to your data from S3 via a bunch of different query engines, and then you can either run your compute on top of that Jupyter notebook instance, or you can figure out some way of taking that compute, creating a Docker image out of that, executing that on Titus, which is our container orchestrator. And then once you were sort of like happy and you had built that model, then you had a variety of different ways to productize that model. One way would have been that, hey, I have this workflow or I have this compute code. Can I somehow orchestrate that on a workflow scheduler? So people would go ahead and they would sort of like rewrite their sort of like prototyping code into something that will fit the schematics of this workflow orchestrator. And then once the model was sort of like available to them, then they would figure out how to integrate that model into the surrounding ecosystem, whether it was like hosting that model as a microservice, or whether it was doing some sort of like batch scoring in a certain context. And now the problem is that for a data scientist, if they sort of like if they're expected to do all of these tasks, then it becomes kind of like a distraction from their real goal of doing machine learning. So when team started, when we sort of like took stock of the situation, we sort of like noticed that there's a big productivity gap within data science teams where they end up spending a lot of their time on engineering concerns. And most of the data scientists, they would much rather have their time spent on machine learning concerns rather than these engineering concerns. So Metaflow was essentially our effort in figuring out that, okay, all of these tools, these underlying foundational blocks, they have existed for a while now. They are well proven out at a huge scale. And can we provide a UX, can we provide a way for our users to very seamlessly move between these blocks so that they don't really have to think about the engineering concerns. Say, if you are a data scientist and you want to train 100 models in parallel on a fleet of GPUs, then you might not want to concern yourselves with like, hey, what is Docker? How do I write a Docker file? If I have a Docker image, how do I run, say, 100 containers in parallel with my code, train 100 different models, and then get those models written back to S3? And while I'm doing all of this, how do I ensure reproducibility and making sure that, if, let's say, I have my colleagues who want to get access to my work, they can get access to that in a much more easier manner, and they don't have to sort of like search for these one-off scripts to replicate these dev environments and all. So that was essentially our attempt at sort of like solving this problem around this big productivity gap. So that's all Metaflow is about.
Great. And so how does it work? What does it do? What's the scope of the product?
Sure. Yeah. So Metaflow ultimately at the end of the day, it's a Python package as well as an R package, because the users that we have internally, they use either Python or R to get their work done. So we have to take care of both of those. And within Metaflow, we have tried to make sure that the number of concepts that they have to learn are sort of like kept to a minimum. So they can write their idiomatic Python and R code, and Metaflow will then allow them to sort of like declare their compute in a directed acyclic graph. So very simply, like let's say, if you have a workflow where you are, say, getting access to some data from a data warehouse, then you are, say, transforming that data, maybe generating some features, then you are training a bunch of models. Maybe then you're trying to figure out which model sort of like performs the best amongst the group of models that you have trained. And then you're doing something with that model, maybe storing it, maybe pushing it elsewhere. All of this paradigm essentially can very easily fit into into a DAG, which is how like most of the workflow orchestrators work at the end of the day. So we allow users to very simply declare this graph, and then Metaflow will take care of the execution of that graph on their laptop. Now, what usually ends up happening is that
on the laptop, you said?
On your laptop, yeah. So locally on your laptop.
Mm-hmm.
And now what ends up happening for most of our users was that, they'll start off with a small set of data, but then very soon they will start hitting the limits of their laptop, where let's say, if you're, say, looking at like a pandas matrix of like, say, like 50 gigs, like all of a sudden your laptop will not be able to support that. And at that point in time, the user essentially needs a bigger machine, right? But then how do you sort of like make that bigger machine available? So within Metaflow, then you can just like drop a few decorators. You can just like tag a particular step and say that, hey, this particular step needs, say, 100 gigs of RAM. And then Metaflow will then figure out how to talk to your container orchestrator, and it will then automatically launch a job on that container orchestrator, move all of your data and compute, and then push back all the results to your laptop, so that then all the other steps of your workflow can continue accordingly. Another example here could be that maybe you want to train a model using GPUs, but then your laptop does not have access to GPUs. So then just for the training step, you can then just like declare that, hey, this step needs to run on an instance with GPUs, and then Metaflow will take care of all of that heavy lifting. And what this allows our users to do at the end of the day is they can be like far more productive when they are prototyping, because now they're not so like limited by the resources that are available in the laptop. And it also,
how does it do that? Like, how does it know that you need a GPU, or that you should be connecting to something else? Like, how does?
So right now we require our users to be explicit about it. So now let's say you have defined this DAG, this graph. So let's say the first step of the graph is that you are playing around with some data set, right? And maybe you need a memory intensive instance for that. So you can very simply just like for that step, throw in a decorator that says that, hey, this instance or like this step needs to run on an instance that has this much memory. And then now for the next step of your workflow, you can specify a different instance or different resource requirements. And then Metaflow will take care of orchestrating that on your compute cluster. And so this is sort of like more so focused on the development environment side of things. And what Metaflow does behind the scenes is that it will also sort of like cache and store all of the intermediate state, so that you can go back in time and you can look at like how a certain workflow executed through any of your systems. And this also allows people to scale out their compute really, really well. An example here could be, like we have users who want to say train models for every single country that Netflix operates in, as well as every single language that Netflix operates in. So you're all of a sudden the cardinality of the number of models that you want to train are in like thousands and tens of thousands. But then training these many number of models in one shot, where let's say each of these models might have significant resource requirements, that could be really tricky for people to just like do their dev work around that. So Metaflow simplifies that job. And then it also allows people to productionize their workflows in a very seamless manner, because now the community has done great work in sort of like building these best of the breed workflow orchestrators. And Metaflow does not intend to be a workflow orchestrator. It's a workflow orchestrator in the sense that when you are in the dev mode on your laptop, it allows for quick prototyping. But then let's say you're happy with the workflow that you have created, and now you want your workflow to execute alongside your other data engineering ETL workflows. Then Metaflow allows you to export your work onto a workflow scheduler without actually the end user ever having to understand or read through the SDK of the underlying executor.
Which schedulers do you integrate with?
So right now we integrate with AWS Step Functions as well as Netflix Mixon, and then we have a few more integrations in the pipeline
that you're working on.
Yes.
Okay.
Yeah.
Very, very good. Sorry, I interrupted you. Well, did you?
No. So I was sort of like trying to give a very general overview of like some of the capabilities that Metaflow has, but like by and large, if you look at, say, the current MLOps ecosystem, it's as big as the software engineering ecosystem by itself, where people have to worry about different layers of the stack. And there are a lot of great open source projects as well as commercial vendors, which are making good progress. Like things like how do you sort of like have efficient data access? How do you manage your compute instances when it comes to workflow orchestrator? What is the story around that? When it comes to monitoring your ML workflows as well as your ML inferencing endpoints, there are a variety of different solutions as well. So, but then the gap is that as an end user, as a data scientist, how do you sort of like move between any of these components? Let's say if you're using S3 as your data store, but now if you're using Kubernetes as your compute cluster, and say if you want to use step functions or Argo as your workflow orchestration layer, and then if you throw in some sort of like monitoring tooling, um, as a data scientist, then I have to sort of like think about like all the best practices around like how do I go about writing my code? How do I go about like snapshotting, not just the code, but the data, as well as, how do I figure out like how to get the right set of dependencies if I want to say play around with TensorFlow versus PyTorch, like a whole bunch of different engineering related questions that a data scientist ultimately has to answer to sort of like get their work done. And uh, with Metaflow, our desire is that you don't necessarily have to think about many of those concerns, and the software layer will take care of that with the UX, which is.
And is that to which extent is that automated as of now? Is that a situation where, okay, I'm a data scientist now, like I just do my modeling, my machine learning, then I press a button and it all happens, or is that a situation where you still need to tweak, but like instead of needing like 5 data engineer days of work, you just need like an hour?
So right now, essentially, what you do is you point Metaflow to your data lake, you point Metaflow to your compute layer, you point Metaflow to your workflow orchestrator, and then using Metaflow, you just like do your machine learning work, and then Metaflow will take care of like, okay, how to efficiently talk to your data layer, how to snapshot all the intermediate state, make sure that your entire workflow is reproducible. It will do dependency management on your behalf. It will launch your workloads onto the compute infrastructure at scale. So all of that is taken care of. You don't.
It's all automated.
It's all automated, so you don't necessarily have to do any other tweaking per se.
Great. And so Netflix decided to open source Metaflow in what, 2019. I'm always curious, like, why does a company like Netflix decide to do that, and what are some of the actual benefits that you have, derived from that decision?
Sure. Yeah. So we open sourced Metaflow in December of 2019 at reInvent, and we have been working on Metaflow for the last 3.5 years. So once we sort of like had near universal adoption internally at Netflix, at that point in time, we sort of like started talking about Metaflow publicly. So that would have been somewhere around like early 2019. And that's when we actually saw that there was this gap in the kind of offerings that were available in the market. And there were a lot of folks who reached out who were curious to use Metaflow. And Netflix has invested in open source projects for a really long period of time. If you look at projects like Chaos Engineering, Spinnaker, so our hope was that with Metaflow, we can sort of like, again, like establish the Netflix brand specifically in the machine learning infrastructure domain, as well as we had some amount of confidence that we had something new to offer. And not just like for us, open source wasn't only about that, hey, like here's some piece of code that we have now made public on GitHub, and now you're like free to use it in whatever way you wanted to. But also it was sort of like a good conduit for us to engage with the community, to understand what are the use cases and pain points, so that we could sort of like learn from a broader set of audience outside of Netflix as well, and then essentially build something going forward that addresses all of those pain points. One thing that I should sort of like also point out here is that Netflix has this really interesting corporate culture of freedom and responsibility, which means that our data science teams, they are essentially free to use whatever tooling that works best for them. And given that Metaflow is ultimately at the end of the day trying to address a wide diversity of use cases internally, also meant that we couldn't necessarily be opinionated about the kind of opinions that data scientists care about in the way that like for example, they care about what sort of modeling libraries they should be using, but not so much about how the data is actually being stored in S3, as long as they like efficient access to S3. So our focus was more around like making sure that we learn from our users internally as well as externally. What are these pain points that they are running into every single day, and can we sort of like then address that in a easy to use package? And with an open source tool, it just increases the amount of opportunity that we have for learning from the community.
Very good. And have you seen companies outside of Netflix use Metaflow?
Yeah. I mean, we've had a great amount of adoption. Like there are companies, in genomics and fintech, social media, who are running all of their machine learning workloads using Metaflow. So the adoption has been great, and I guess now it's all about like what comes next.
And what kind of company do you need to be? What kind of requirements do you need to have to be a good fit for Metaflow, or for Metaflow to be a good fit for you?
Mm-hmm. So Netflix is an AWS shop. So the current first-class integrations that we have with Metaflow are for AWS. We are working on some projects that will essentially change that situation in the near future. But by and large, as things stand today, if you want to sort of like run your machine learning workloads natively on a cloud, then we provide integrations with AWS. So that's one sort of like requirement of sorts. But then you can also run Metaflow locally on your laptop, and you can still sort of like benefit from data versioning, reproducibility, collaboration, and a lot of organizations do use that for that. So our focus with Metaflow's release has been to be sort of like to cater to data scientists rather than machine learning infrastructure teams. So a big majority of our users are essentially companies who have made serious investments in machine learning, but for one reason or the other, they don't want to invest too much into machine learning infrastructure per se. So Metaflow sort of like provides them an easy way of adopting something that has worked at scale at Netflix. So if let's say there's an organization which wants to use Metaflow, all they need to do is just like pip install our package and point it to their AWS resources. The deployment footprint that we have is fairly minimal. So yeah, in terms of actual like engineering investments that a company needs to make to bring in Metaflow to make sure that all of their data scientists are using that, we have tried to make sure that it's kept to a minimum.
Very good. As we are almost out of time, one last question related to this from Rodrigo. Sounds really great. Maybe give a hint about when not to use Metaflow. So I guess one answer is if you don't run on AWS, but what?
So if you don't run on AWS, that's sort of like a partial answer in the sense that you can still sort of like benefit from a lot of functionality that Metaflow offers on your laptop. But then at the same time, there are certain instances where you just don't need sort of like an MLOps solution, right? Many data scientists, or many use cases are completely okay running with like one-off scripts. So that's completely fine. Another thing is that we've essentially focused on Python and R. So if let's say your use case focuses on a different language, like for example, a decade ago, most of machine learning innovation was happening in Scala and JVM languages. So if let's say you have already built an ecosystem in that world, then Metaflow in its current form may not really be that useful.
Okay. Very good. On that note, thank you so much. This was wonderful. Really appreciate your stopping by, and it's it's amazing to think of Netflix as the final product that we all know and love, and it's amazing to get a glimpse for the level of just amazing technology that's behind it, and the quality of the teams, and how leading edge this all is. So wonderful. Thank you very much. Really appreciate it. Thank you so much.
Great. And we'll call it a close. Thanks a lot, everyone.
Great. Thank
Matt,
you. Thanks, everyone. Yep. Thanks, everyone. Really appreciate everybody that comes to these events on a regular basis. And the next one to be confirmed, but the next one is on March 9th as of now. So we'll be sending invites, but be on the lookout for it. Should be a great event as well. And thanks, everyone. We'll call it a wrap, and we'll see you next time.